As you just saw, we completed the part using a rotary 4-axis cut. Now we are going to finish the part again using a different cutting method. This time we're going to use a rotary 4-axis with axial cut. A rotary with axial cut toolpath is used to create a 4-axis surface machining toolpath which cuts along the axis of rotation of the machine. In our case, it would be the x-axis. With that being said, come up to the top and select toolpaths and go to multi-axis. When this loads up, select rotary on the far right hand side. Come over to Tool and make sure you choose the same tool which we used in the first two operations. Insert the comment, finish the right side cam using rotary toolpath with axial cut. Once you have your comment in, come over to the side and select Cut Pattern. In Cut Pattern, select Surface, and grab this surface here. Once done, hit Enter on your keyboard. Under the Cutting method, we are going to turn to Axial Cut. Once that's on, come down to here, Stock to Leave on Drive Surfaces, and remove the value to 0. Once this is done, come down and change the direction of open contours to zigzag, and leave the direction of closed contours to be climb. On the left hand side, go to Tool Axis Control. Under Tool Axis Control, we are going to make the maximum angle increment to 0.5. We are going to make the start angle 0. The sweep angle we are going to make 360. And hit Enter on our keyboard. The Tool Axis Control setting determines the tool's orientation in relation to the geometry being cut. The maximum angle increment, right here, sets the angle the part indexes between passes in degrees. The space between cuts will vary based on the part geometry. The start angle sets the angular value to begin the toolpath. The angle is applied relative to the tool plane used to cut the geometry. The sweep angle, here, sets the angular value that determines the range of the axial cuts. The angle is measured from the start angle value, and tool vector length, here, controls the toolpath display by determining the length of the tool axis at each tool position. Recommended value is 1 inch. With that being said, come over to the side and select Linking Parameters. Change the clearance to a value of 4. Make sure retract is off, feed plane is 1.5, and the percent of tool diameter we're going to change to 1000, and hit Enter on our keyboard. Select OK when finished. Once this is done, our toolpath will look something like this. From here, we will select only the file number 3 and run our backplot. Select the play button. Once this is done, we will go ahead and select Exit. Go to the Parameters page and go to Collision Control. Under Collision Control, turn on Check Surfaces and select Check Surfaces here. Go to QM Color on the very side, located here, and make sure that number 56 is the only one selected, or this kind of purplish, grayish color. Once that's selected, select OK and hit Enter on your keyboard. From here you should have 2 check surfaces and Stock to Leave should be a value of 0.0011 and hit Enter on your keyboard. Once this is done, select OK. And run your backplot again after regenerating the dirty toolpath. Select the backplot and select End. Your backplot should look like this. Close the window, come over to the left side, and toggle your toolpath display.